Ladies and gentlemen, before we start, I would strongly advise you to move forward. This lecture will show you a couple of very beautiful pictures, and you have a much better impression if you sit in one of the front rows here. Ladies and gentlemen, I would like to introduce to you now Mr. Gunter Schreier. He is the Deputy Director of the German Remote Sensing Data Center. This is a unique center not only in Europe but worldwide. At this center they collect data from all kinds of Earth observation satellites, whatever is available and suitable data, and what they do with it, they turn it into usable data for all kinds of purposes. And this ranges from climate change up to things like urbanization. Now, the special images that will be shown to you originated from a so-called open initiative between UNESCO and the European Space Agency, ESA. And the initiative was to use remote sensing data to help UNESCO in managing their World Heritage Sites. The initiative came from UNESCO and ESA, and DLR came into the game because of their unique skills and data archives, and also because they contribute data of a German satellite, TerraSat. What you will see today is not only beautiful pictures, there's a lot of background, and there's analysis of these pictures that will be explained to you by a world expert. Dr. Schreier, please come and have the floor. And again, I would only advise you, please move forward. You will have a much better impression of the images.
Please. Thank you. Thank you, Professor Feuerbacher. Ladies and gentlemen, distinguished guests and participants of this IAC2009 in Korea, I have the great pleasure to be here in Korea and in this beautiful town of Daejeon, and I feel honored to give this highlight presentation. In this highlight presentation, as mentioned by the chairman, I like to link the wonders of our culture, the architectural sites, but also the marvelous sites of our nature. I like to link them with the marvels of space engineering, of the achievements of space technology, of Earth observation. The first ones, the cultural wonders, are summarized in what is called the World Heritage, which were introduced already. And the second, the engineering wonders and achievements in space engineering, are highlighted here in this week at the IAC 2009 conference in Daejeon, where engineers, scientists, businessmen, and space agencies met. One of this space agency is the German Aerospace Centre, in short DLR. If you like to know more about DLR, not only space projects, also energy and traffic, we have a booth there, exhibition, feel free to come. Actually, there's tomorrow a short dinner, I think, or some kind of reception, so please go there. Some might have noticed that this presentation was initially announced by the chairman of DLR, Professor Werner. He was forced to stay in Germany on a short notice. You might have learned that we have a new parliament in Germany. So he asked me to step in. As Professor Feuerbacher named, my name is Gunter Schreier. I'm with DLR, I'm with the German Remote Sensing Data Center, and I'm responsible there for European and international projects. And my aim is to link Earth observation with new applications, with new sciences, with applications of Earth observation, and even the public and general public. And Earth observation technologies, DLR has a lot to offer in Earth observation technologies. This presentation, though, is not just about DLR satellite data, not only about DLR Earth observation data. We are involved in ground segments and data archives and data distributions, and moreover in projects using Earth observation data with many national and international partners. So we benefit very much from the use from other sources besides those of DLR. We are involved in many application areas, as already mentioned. Global change on the global scale is one issue. Urbanization, civil security is another issue used by DLR applications. And in this international framework, actually, can you dim this light down here? This international framework, this working with international partners and the working with new and enhanced very high resolution data, as you'll see in the presentation, has given us the ability to support UNESCO in their aim to preserve the natural heritage. If you walk on ground and if you encounter such a World Heritage Site, you might notice this sign which is marked at these sites and says, this is a World Heritage Site. World Heritage Sites are enlisted in the World Heritage Site Convention. Actually, we have about, nowadays, 890 of these World Heritage Sites. It's not only about architecture and like historic monuments. These are about 689 cultural sites. It's also about the wonders of the nature, as I show you, about 176 pure natural sites, and some of them, 25, are mixed. They're all over the world. I learned in this brochure, which were distributed here at the entrance, that Korea alone hosts about 10 World Heritage Sites. Sites which are remotely as in deserts and on islands, but also sites which are in metropolitan areas. And the purpose of the World Heritage Convention is to preserve sites from threats, to preserve these sites to be available for the nations, for the generations to come. One of these threats is done by ourselves. Our very presence as a tourist, for instance, at these sites, especially the natural sites, could threat these sites. And of course, the threats we have generated by our urbanization, by environmental pollution, and finally the contribution we have made to global change, threatening also World Heritage Sites. Thank you very much for dimming the slide down. Also, natural catastrophes like earthquakes and fires are endangering the sites. Throughout my presentation, I will show you a variety of these threats and how Earth observation can be used and is actually being used to help UNESCO and the member states of UNESCO to preserve their natural wonders. Now, if you talk about wonders, everybody reminds the wonders of the antique time, the 7 world wonders. Only one of these 7 has made it to modern times, the pyramids of Gizeh. In fact, the pyramids of Gizeh, apart from the polished stones which have formerly covered the pyramids and are mostly gone, the pyramids of Gizeh are basically untouched since centuries, since thousands of years. If you look into detail and want to see some changes which are not tracing back to hundreds but just months or some dozens of years, you might need radar such as these Terrasa X image. Terrasa X is good for monitoring subtle changes, while just putting in these frames an image of 2007 and 2009 on top of each other, and you see the subtle changes in a different color than black and white. Apart from the changes in the parking lots, you might notice about here some changes ongoing from recent archaeological excavations, depicted a little bit in color. Now, the threat to the pyramids is not so much from tourism, which is, and not too much from archaeology, which is, but the threats to the pyramids is basically by the growth of the city of Cairo. Now, since about 1972, monitoring the growth of a city, you have to rely on old documents, you have to rely on ground-based surveying and maybe aerial photography in the early 20th century. And only from 1972 onwards, we have the satellite means with the early Landsat satellites to monitor in a time series the urbanization of. So this was done with Landsat, and meanwhile, as you have heard in this conference, we have many more of these satellites following Landsat. Landsat 7 is the one which is actually in space, and followed by satellites from other nations with even more capable capacity. So cities are growing, so ancient monuments, necropolis, which are deliberately built by former emperors outside their capitals, are now engulfed by urbanizations, by cities, by roads, by land use and pollution. In other areas, also other kinds of man activities are threatening World Heritage Sites. Again, a radar image from Terasa X. Here it's not the urbanization. Here we have a climate where farmers like to plant plants for nourishing their families, to trade with agriculture goods. So this is how Angkor Wat, Cambodia, is endangered by nearby farming and by agricultural activities. Machu Picchu in South America. Steep slopes and about 2,000 and more than 2,000 tourists per day endanger this natural heritage in Peru, in its monument in Peru in South America. The steep slopes and the tourists led up there by trails, by streets and even cable cars made these steep slopes and the soil moving downhills. You can monitor the slight movement of slopes of soil with a technique called radar interferometry, and I'll show you some examples of these radar interferometry later in this presentation. Radar has also managed and imaged Venice, another World Heritage Site, as seen with the multi-temple Terasa X scene. Venice, like Machu Picchu, is threatened by tourists. 18 million tourists per year visit Venice, with only 60,000 resident inhabitants in the old Serenissima. Venice also is threatened by a small subsidence of the entire ground. So Venice is going a little bit down because groundwater is taken from reservoirs underneath Venice in the Adriatic. So in general, global change is done through mankind. This global assessment depicts the change civilization has done from its earliest time, and every red dot is about 20% of the landscape at least has been changed by civilization. Some of these changes trace back to old cultural areas and some are more recent. Man is taking possession of land. Not only land on the same big continents, but land as remotely as 1,000 kilometers away from the coast of South America, the Galapagos Island. Galapagos was discovered in 1535, but only got famous when Charles Darwin set foot on Galapagos in 1835, and discovered some species which are unique only on Galapagos. The name is endemic species. Pirates and early settlers brought more species, more plants to Galapagos, which are now threatening the natural environment of the endemic species. Let's go back to the mainland of South America. Forests. Forests play an important role in the carbon cycle. Forests like this World Heritage Site, the National Park of Iguazu, are likewise challenged by human acts. Again, this is showing a picture of the border between Brazil and Argentina. On one side it's taken care of, the forest is intact, and the other side the forest is damaged or taken by agricultural use. Forests again form an important factor in the global carbon cycle and therewith in assessing and understanding global change. In about 40 years or so we have access to Earth observation data. We can monitor the change of forest. Like this forest from 1985 in Paraguay to the use, the land use, the farming in now 2003. Jumping over the Atlantic Ocean back to Africa, to Kenya. Mount Kenya National Park was established in 1949, and Mount Kenya National Park, lots of species, hosts a variety of flora. Now it's hard to distinguish flora and plants from space. With your naked eye, you just see a very narrow part of the spectrum, and this image is just representing here a picture of red, green and blue. If you really like to understand the content of images, multispectral scanners use more than red, green and blue. Maybe 4, maybe 6, maybe 16 channels, even in spectra which is not accessible to the naked eye. But if you really want to understand what kind of species you have in front of you, what kind of plant stress or crop growth is going on, you need to explore more spectral bands. You need to go to 256 or even 500 spectral channels. Such spectrometers or hyperspectral scanners are good for doing this assessment, and by 2003 DLR will add to a fleet of already now existing spectrometers and hyperspectral scanners in space a unique instrument, an even more precise instrument called EnMAP or environmental mapper. Here you can see that grass is not just simply green, it consists of more of just grass, and that the sea is not just blue or has different shades of blue. Coming to the sea, coming to the coast, the North Sea coast of Germany. Now Germany has not this large coast as Great Britain or Denmark share with the North Sea, but the unique landscape of tidal currents, of mussel banks, of grassland, named the Wadden Sea, is also named a World Heritage Site. DLR and others are monitoring this World Heritage Site, the Wadden Sea, with various kinds of sensors doing environmental assessments year-round. Now, to understand the Wadden Sea really, you need to monitor the ebb and flow of the tides, not only on a day-to-day basis, but maybe over a long period of time. Northern Germany, the Wadden Sea, is not a country which you can say you have always clear skies and you can do optical assessment. So a tool to use is radar imagery, once again, which can penetrate clouds, can work in bad weather, and can deliver this unique information all year long to assess heritage sites like the Wadden Sea in Germany. Going from the sea to the polar areas. This polar area, the South Pole, the Antarctica, the ice sheets of Greenland, hosts most of the frozen sweetwater on Earth. Understanding the dynamics of glacier is therefore important to understand mechanisms of global change and finally also understand sea level rise. This is the Jakobshafen glacier in Greenland, which is supposed to be the fastest moving glacier with about 22 meters per day. But how can you assess this flow of a glacier from space? How can you see features on this what it seems to be featureless and just white surface of the glacier? Again, radar might help to do this, and thanks to the unique capability of radar imagery, like TerraSAR-X, of geometric position, you just can put the observation of radar on top of each other and can display this small movie. So you see an ice glacier, now it's in Antarctica, the Drzealski Glacier in Antarctica, in about 9 months period flowing to the Antarctic Sea. What you see here coming up as light and dark is not the change of the day, but it's just the seasonal change of the melted ice on top of the glacier, and there with the different reflection of radar. We stay with the poles, And the poles, Arctica and Antarctica, have not only famous for their beautiful landscape and for their importance for global change and understanding climate change, they are also good for us, the space engineers, because polar orbiting satellites, as the name implies, circle around the globe while the Earth is spinning underneath these satellites. So on each orbit, polar orbiting satellites pass over the globes. So if you like to get data from these satellites downlink to Earth, if you like to command satellites up to the satellite, you have to make sure that you have stations which are near the polar areas, and DLR is happy to have pioneered the first station, satellite reception station in Antarctica. Meanwhile, we have also a station in Spitsbergen, and also recently, together with international partners, with local partners, with agencies and industries, we have also a station established on a Canadian compound in Canada, together with the Canadian Space Agency and the Canadian Centre for Remote Sensing. Now, so far, I've given you just an overview what can be done and possible, and can possibly be done with Earth observation. I like to come now to a project I was really involved in. So apart from it could be done and it should be done, we were faced with a very concrete request by German archaeologists in 2006. The German Archaeological Institute of Berlin is doing excavations in an historical site in Iraq named Uruk. Uruk, in fact, is the first settlement, one of the oldest settlements of mankind. In fact, it was the largest known city to about 600 BC. Uruk, for some of you, is also famous because the earliest, not Romans, the earliest literature of mankind, the Gilgamesh epos, is playing in Uruk. Now the question was that the measurements and the excavations and archaeological research the German Archaeological Institute has done since the early 20s and have concluded with geophysical measurements in 2001-2002 will not even be possible after the Iraq war starting in 2002. So the problem then was that organized crime is taking place on some of the archaeological sites, and bandits and gangs are basically looting these sites and taking away archaeological artifacts from these sites. So the question is, can we help the archaeologists in detect possibly looting from space? At this time, the image we had in our hands and available was at this time the best high-resolution imager, the Iconos imager, 1 meter resolution from space. So we used this as a tool to merge this with other available data to possibly find lootings and other traces from space. Nowadays, we have also TerraSAR-X data, but this was available after the project. This is the kind of data DLR donates to scientists for scientific and archaeological use, also for supporting World Heritage conservation. Back to our topic, what has been done in Uruk. So I mentioned there have been geophysical measurements done. This is not from space. This is a few geophysical magnetometric measurements. So here a magnetometer is just scanning the Earth, and the subtle changes in the response of the Earth's magnetic field can already here, as you see, display features buried in the ground. This is nowadays a common archaeological geophysical prospective method. Now, whilst the magnetometer used is a latest state-of-the-art eye technology, the working with the non-metallic wooden frame and just walking the scan lines in the hot Iraqian sun is really hard work, as shown here by my geophysical colleague Helmut Becker, who has done the measurements in 2001 and 2002. While I show this, it is remarkably that the traces, you might see this, the traces of this geophysical measurement team just walking in the desert, putting the sticks, the measurement sticks, 1 meter to each other, were visible a few months after with this 1 meter resolution Iconos image. Remarkably, astonishingly, how these footsteps can be seen from space. but also frightening how footsteps, just the simple presence of man, can change a very fragile landscape and can do possibly damage to a fragile landscape. Coming back to the major theme, can we detect looting from space? Now luckily, the site of Uruk, the archaeological main site of Uruk, wasn't hit by looting. This is also thanks to the good relations of the German Archaeological Institute to a local sheikh and his tribe, who really have guarded this. But nearby, we found a hill, which is called a tell. So this is how the tell looked in 2001, before the conflict. And if we're talking of looting, we're not talking about doing an excavation here and there, and this is a helicopter image taken also in Iraq, I guess, which shows looters at work. So this is really organized crime, digging into a mountain and digging into archaeological sites like in Swiss cheese. So this is then in 2005, 4 years after, how this tell looked like. Now, dealing and trading with archaeological goods is a crime if you do this illegally. This is one of the issues, but the major issues, the World Cultural Heritage Conversion is concerned, the archaeologists are concerned, is that while the looters have done this work here, the archaeological context, the historical context and parts of our culture is gone. The archaeological site is useless. The context is gone, which is preserved like 5000 BC in these clay tablets. This is our history. Nowadays history, again I said about tracing back 40 years, we, DLR and other spacefaring organizations preserve in new technology, latest information technology and storage technology archive. The challenge here, likewise we share with other organizations, is not the terabytes and petabytes of data. This can be managed. The challenge is that the archiving, the storage technology, changes every other year. So we are just behaving more or less like medieval scribes who transfer the old culture or the recent culture of Earth observation from one parchment to the other, from one storage technology to the other. This is our daily business. Going back to technology, going back to radar, radar technology is not just measuring the amplitude of the return signal, but the phase. And if you deal with these phases and put two images basically together, two phase signals together, you get what is called an interferogram. This interferogram is good to derive the topography of the Earth, and this is what our next mission, Tandem X, is about, a twin satellite configuration good for measuring the entire topography of the Earth. If you subtract these changes in phase, you end up with so-called differential interferometry. With differential interferometry, you are able to detect very, very slight movements, millimeters, in fact, can better understand earthquake mechanisms, landslides, and soil subsidence. And this is how some of the cultural heritage sites, like soil subsidence, hang slides, are endangered. You can measure this. Or they're endangered by earthquakes, as have been dramatically seen here in the city of Bam, and the historic castle of Bam, also World Heritage Sites, was dramatically damaged by this 2003 earthquake in Iran. Now, while Bam is really, and the castle of Bam is really a landmark for the Orient, an occidental landmark, a landmark of European culture, is really Greece. Greece is the heritage of the European culture, amongst others. Greece nowadays and the Mediterranean areas are endangered by other natural disasters. Buildings, land use, and historic artifacts and sites are endangered by wildfires. You can rightfully argue whether all these fires are really established by its own, by nature, or just done by men. Nevertheless, Earth observation is nowadays helping, not to prevent only, but to detect Earth wildfires like those you see here in Greece. Moderate resolution MODIS, MARIS data from NASA, from ESA, is nowadays used to do these wildfires, to map these wildfires throughout the Mediterranean and in other areas of the world. In the framework of the European Global Monitoring of Environment and Security Program, the mapping of natural disasters is one major issue. We have advanced our capabilities, our technologies, and our access to data, put together what we call a satellite-based emergency service, or in short, ZKE, as the German abbreviation stands. So we do crisis information, and again, therewith we demonstrate the capability of DLR to react on a 24/7 basis as a quasi-operational service. In August this year, Greece was again struck by wildfires, even wildfires nearby Athens, and this is a part of the analysis where you see here wildfires approaching Athens and also endangering cultural sites. A part of the analysis which is not just done on one specific data set, but many, many specific data sets need to be put together. There is a request and a need for international collaboration, which we do in the framework, for instance, of the Charter on Space and Major Disasters. International collaborations in Europe, like MES, but also the international collaboration in the framework of GEO and the system of systems of GEOS, aiming to get to a real operational 24-hour service on emergency response. Operational, all day-long, yearly services are known since several years in operational meteorology, in weather forecasting. With new polar orbiting satellites, polar orbital meteorological satellites, we are now able not only to help to forecast weather events, but also to measure trace gases and pollutants in the atmosphere. One of these pollutants is, for instance, nitric oxide, which can be measured here from space and which is done at DLR and other facilities on a daily basis. So these pollutants, of course, form a permanent threat also to buildings, to marbles, to stones, form a permanent threat also to monuments and sites of archaeological heritage. In general, the global picture of nitric oxide looks like this. It's important to understand how this behaves. Luckily, due to better catalysts in cars and to more efficient power plants, the NOx, NO2 exhaust in Europe and America has been reduced, but is now taking over a little bit by the blooming economy of China. Now, during this presentation, I tried to show you the link between our cultural heritage and modern space technology. And I think we are now advanced with modern space technology, not only Earth observation, that we have at least responded to the old human quest of looking beyond, what is in outer sphere, and when we are in outer spheres, what is down there on Earth and what's going on Earth. This presentation, part of the images and the motivation to help World Heritage Conservation sites with Earth observation data, was somehow motivated by two international and European organizations situated in the city of Paris. This is one of the latest GeoEye 150 centimeter resolution imagery, which actually also is processed at DLR. So you see in the center the 3-star building of UNESCO, and you see here nearby the ESA headquarters building. Both organizations have pioneered and created what is called the so-called Open Initiative to help with space technology. In fact, it's not only Earth observation, also communication and other space technology to support the World Heritage Convention. 2 years earlier, 2 years from this, 2 years ago, in December 2007, in fact, it was motivated then at the IAC in Hyderabad, so the last but one IAC, DLR also joined this initiative. And our objectives there is again the same objectives as initially ESA and other meanwhile members of this open initiative to support with our data, with our information and with our projects UNESCO and support the conservation of World Heritage Sites. Let me conclude this presentation with this final picture of Paris. Actually, the banks of the River Seine and the monuments of the River Seine are also a World Heritage Site. Let me conclude with mentioning that all this preservation of World Heritage Site, all using space technology, should not be an aim in itself, but should be used to foster the cooperation between mankind, the peaceful cooperation between states, or, as the topic of this convention says, space for sustainable peace and progress. Thank you for your audience. Thank you for your patience.